Great to be here. I'm here to talk about maps, more specifically how to build maps, how to update and fix maps in a scalable way. So we're living in a time right now where the demands on map data being accurate, being updated, coverage growing and expanding is getting increasingly higher and higher, which means we need to find more scalable ways to collect data, and we need to find more scalable ways to make sense of that data. And those are the two main problems when it comes to building and updating maps at scale: collecting enough data and then making sense of that data in a way that doesn't require thousands of manual workers looking through everything. So that's what I'm here to present. I'm from Mapillary. We fix maps with the help of crowdsourced imagery. And so when it comes to, imagery is one of the fundamental building blocks for creating data for maps. So there's satellite imagery, and then there's street level imagery, which is what we do at Mapillary. And so you've probably seen mapping vans like this from some of the major mapping companies driving on the roads of your cities. This is how data for maps is typically created. So you drive around, images in a controlled setting on a mapping van, and you drive up and down with every road with a fleet of vans. And the problem here is that it's very expensive. So each van like this costs several millions, and you don't have that many. So a large fleet today is measured in the hundreds. So if you're going to go from the coverage that you have today and the update frequency of maps today that doesn't even fulfill our needs of 2018, you need to find a new way to do this. And so what we're doing is we're opening up data collection to any device. And when you think about any device, there are primarily two things that will give significant contributions here. So the first one is smartphones. So there are just over 2 billion smartphones in the world today. All of them have cameras. All of them have, or most of them have GPS, other onboard sensors, and processing capabilities, which means that on every street in the world today, there's someone with a device that can do data collection for mapping. The second and very interesting category is cars. So there's just over 1 billion cars on the road today. Most of them don't have cameras. Most of them don't have onboard compute, but that's rapidly changing now with the transition to autonomous vehicles. So there's more and more cameras being deployed in more and more cars, and over the next 5 years we're going to see a dramatic shift in the automotive space when it comes to data collection for mapping as well. So the problem is, though, is like if you open up image collection from this controlled scenario of you importing imagery from your mapping vans to anyone can collect images anywhere with whatever they have, you face a couple of difficult challenges on the technical side. So you need to build a fairly deep tech stack. So this video shows an example of someone driving with a cell phone camera mounted in the front of a car. It does labeling of all the pixels in all the imagery. It does object recognition, positions all of these objects with latitude and longitude, lane estimation, all of these things that you might have seen in some of the self-driving demos, some of the autonomous technology for perception, except that this is then applied on the cloud side, where we have collected imagery from many, many users and we correlate it together, which means we can build 3D models of every place where people take pictures, and we can then find and position objects inside of that. So with this, so this illustrates some features and some objects that have been detected and positioned and then published as map data. With the help of this, we can now have a fully scalable model for generating map data worldwide at almost zero cost. And so if you look at our platform today, so Mapillary has been live and operational for just over 4 years. And we have imagery in 190 countries. We, like I showed in the video before, we extract map data from those images completely automated. We publish the imagery and we publish the map data. And today, if you go to our website, you can find about 34 billion map objects and 400 million images, that you can all use for whatever you need to do. So if you need to update some geodata set, or if you need to build a map, or if you need imagery for your routing app, or whatever it is you want to do, you can get it from this one central repository. And so the interesting thing here is that we now have what we think is the world's second largest public street imagery database. And we didn't capture any of the images. Other people did. So you got citizens, you got activist groups, you got cities, you've got all the commercial actors in that city, and all of the mapping companies generating data together in one collaborative data set. And so if you look at where we're going, there's going to be more and more connected cameras. There's going to be more and more connected sensors all over the cities. And this type of machine-generated, automated understanding and sort of generate data that you can use directly will help cities, will help us build better maps, and will also drive our cars more safely in the years to come. And so the pieces that we bring to this that I think are super important is the collaborative model, it's the scalable data collection, and sort of doing this together in a way where you're actually, it doesn't have to cost a lot of money to generate this, and that's what we do. So that's all from me. Thank you.